In this video, we're going to be covering the new tool from SCHUNK, the design tool for grippers. First, we need to get to their main website at www.schunk.com. At the main site, under the Services tab, you're going to see the digital services and then the design tool for SCHUNK. Just by clicking on that, it takes you to the design tool for SCHUNK grippers. This tool is designed to take all the parameters of your application, insert them into this, and then give you a listing of grippers that are capable of doing the job. So depending on how specific you get with the information that you put in, you're going to get a specific list out. Again, this is any gripper that can do the job, not necessarily a gripper you would use in your application. For example, you're going to find a lot of grippers that have extreme force that are not required for your application. So as we start here on the basic data, you're going to see your gripper type, your required safety factor, and operating pressure. On the type, if you scroll over the I, you're going to see what they're looking for in this area. For example, here they're looking for a parallel gripper, angular, or centric grippers. We're going to stick with the parallel gripper, and the required safety factor, we're going to use a factor of 2.0. This is what the applications engineers at SCHUNK will use, and they recommend to stay at this level or higher. If you go below it, you definitely want to get them involved. Your operating pressure can be selected in bar or PSI or different values. And then we get down into our workpiece. This is the part that we're actually grabbing. And there's a lot of specifics that we can enter here. Usually most people are very concerned with this bottom one on the mass of the part, and here we're just going to enter 1.0 kg. We could change that to pounds if we wanted, but we're going to leave it at kg. But then up here you're going to see position for force application point. This is where you're actually going to be touching the product relative to the face of the gripper itself. If you look at this, these are your Y, X, and Z locations from the face of the gripper. So usually we're very concerned about how far away from the face of the gripper we are. Here we're going to be very conservative and enter 1.0, which is of course in millimeters. The position of the workpiece's center of gravity. If you're grabbing a part that's rather long and you're grabbing it on one end, your center of gravity is going to be offset either in the X, Y, or Z. It's almost always offset in the Z, and again I'm going to be conservative here and put in 1 millimeter. Now we scroll down and we get into the gripping situation. More detail on the application. On this one we're looking for the force fit or form fit. Those are your two choices. A force fit is just clamping down on the part as hard as you can, and then a form fit actually has fingers that form fits to the part. These can get pretty specific to a part. The more specific, the less force you actually need. We're going to utilize a force fit, which is probably the most common. Then we want to know if you're on an ID grip or an OD grip, inside or outside, and your minimum stroke of the jaw. If you have, let's say, multiple parts in here that you want to be gripping, your jaw stroke is probably going to have to be larger. But here we're going to enter 1.0 millimeters. Next comes your coefficient of friction. If you scroll over the eye, you're going to see that they default to a 0.1 coefficient of friction, which is steel on steel, dry. You can see here some examples of that. If you know exactly what you're working with, you can enter it here, but if you don't, a default of a 0.1 is rather conservative. Your fingers come into play because this is going to affect how the gripper, what kind of bearing surfaces you need in the gripper and the force of the gripper, all that plays out. So here you want to enter the weight of your gripper fingers. Finger 1 is going to be 1/4 kg, and you'll notice that down here on finger 2 it automatically follows. It might not be the case, and you can change that. Here's your position of center of gravity for the finger itself. We're going to just put in there 0.5 is the center of gravity. And finger 2 could be different, although most of the time it is the same. Again, 0.5 on the Z-axis. Length of the surface. This is how much of the surface of the gripper finger is actually being applied in the Z, Y, and X direction on the part. You have to enter something here. I'm going to enter 1.0 on all three as basically the surface area that is being touched in millimeters. Now we can continue to external loads. This actually flips into a new screen, and these are your process loads. If you have, for example, in your application, you're grabbing a part with a robot and one of our grippers on the end of it, and you're polishing or grinding it, you're going to be exerting a load on the part externally by pressing it into the grinder or the polisher. If you're assembling something and you grab a part and you're snapping it in, that's going to be exerting an external force. This is where that kind of data would be entered. Position of the force application in an X, Y, and Z. How much of a force is there in the X, Y, and Z, and then the moment that's created in that X, Y, and Z. For this application, or for our demonstration purposes here, we're going to ignore this data. The gripper position in space, this basically, if you know the gripper is going to be located in a particular orientation in space, Z-axis is where the gravitational attraction is checked here. This would be with the fingers pointing straight up or pointing straight down. Gravity's working for or against us in that Z-axis. Down here you get involved with acceleration. This often we're moving a part with the gripper, and the acceleration has a lot to do with the force necessary to make sure we hold on to a part. We're going to leave those alone at this point. And down here we can continue on to configuration results. So here are our results, and as you take a look at this page, we have at the top of the page a bunch of filters. Okay, in the middle of the page we have all the grippers that are capable of doing our application, and you'll notice there are several pages, 32 pages here. But again, this is every gripper that SCHUNK makes. By the way, SCHUNK has the widest variety of grippers available from any manufacturer in the world. So you've got 32 pages of grippers that are going to do this relatively simple application. You would never use some of the larger ones. So if we come up top here, we can begin to filter out things. For example, in the drive, electric gripper, or do we want a pneumatic gripper? In our case, we're going to select pneumatic, and that takes it down to 27 pages. Let's say we have a particular series we want. We have a lot of a particular series, or we've used a particular series previously. Let's say PGM Plus. So now I'm in pneumatic PGM Plus grippers that will do this application. We've got 6 pages of those. So you can filter out here, and then you can also, with these items, the characterization ID suitable across the group here, we can sort all those grippers based on this. For example, let's say on stroke. I believe I said a millimeter stroke out of each, so this PGN Plus 64 has 6 millimeters of stroke. That's quite a bit. So if I go here, I can get into a PGM Plus 64-2 with 3 millimeters of force. We could also look at gripper weight if that was a big determinant for us. We can get to the smallest, or 37 kilos in a gripper that of course we're not going to use. So let's say right here we want to stick with our PGM Plus 64-1. It's going to have 6 millimeters of force. It's going to weigh 0.28 kg, and our max figure length is 90 millimeters. So if we click on that, it's going to automatically jump us down to the bottom of the page. And this is where it's going to pull up the grip force, and we're using 74% of the capable grip force of this gripper. In the ZF, we're only using 1.4. As you'll remember, we didn't enter any of the moment loads ourselves, so nothing is registering here. But let's say we want to go with this. We can do a couple of things now at the bottom. We can print a summary, and to show you what a summary looks like, here is the summary. This is all the summary data, and it's 4 pages of what we just entered. Okay, parallel gripper, the pressure, the weight of the part, process forces, and then the PGN 64-1 that we chose, and then the specifications of the PGN 64-1. and then a little bit on the auxiliary sketch axis loads, things like that. So that's what we get in the printed summary. But in the continue to product details, if this is the gripper that we want, we can click here, and that now kicks us into a page, a brand new page of the SCHUNK website that's going to give us all the detail on that particular part. So if I've determined this is the guy I want to use, I want to pull down my drawing, boom, here it is. Here's all the specifications. Again, we had this on our printout, and all the accessories for that. Takes you right into selecting. It's a very nice and easy, seamless approach to selecting a gripper. In the previous page, if we click back to it, of course we've got all of our information here, and let's say I wanted to go with the PGM Plus 64-2, and now I want the information. I can compare and contrast the specifics on those on the two web pages that are pulled up. So as you can see, the tool is very simple to use. You can enter as little or as much detailed information as you need. And please understand, if you want to work directly with our applications guys, you can certainly do that. If you have any questions whatsoever about this tool or any other tool from SCHUNK, please don't hesitate to call us at Leidy Automation at 440-546-1019. Thank you for viewing our tutorial.